A relation is any mapping or pairing of input values with output values. Remember, input values are the x's, output values are the y's. So if I give you a mapping diagram like down here in number 1 and 2, that's input x's and output y's, and then it links the points together. So like in number 1, one of the points in here is -2, 6. Another ordered pair is -1, 5. We've also got 0, 7 and 0, 8. If I had just given you the list of 4 ordered pairs, that would also be a relation. A graph, like down here, if we plot the points on the graph, that is also considered to be a relation. Any pairing of x values and y values, inputs, outputs, is a relation. The domain is the set of input values, the x values. The range is the set of output values, the y values. We'll talk about function in a second. So for number 1, what is the domain of the relation shown in number 1? What are the x values? What are the input values? -2, -1, and 0. What is the range of the relation? The y values, the output values. 5, 6, 7, 8. Then the next question is asking, tell whether the relation is a function. A function is a special type of relation where there is only one output for each input. Each x can only belong to one y. So I want you to write under here, each x belongs with only one y. So when we look at number 1, there's a little bit of a problem right here, because the x value 0 belongs with the y value 7. The x value 0 also belongs with the y value 8. It's kind of like this x value is dating more than one person, and that's bad. That's bad, by the way. That's bad. You should not date more than one person at one time. So number 1 is not a function. And today we're going to talk about multiple ways to identify when a relationship is not a function. So if you're looking at a mapping diagram, if you see that one x value is pointing at 2 different y values, it's not a function. In a list of values, see how the 0 x value appears in 2 points? If you have a repeated x value, it is not a function. So you might want to put a note in here, repeated x value. Repeated x values are bad. Now let's try number 2. First, the easy part. What is the domain for number 2? 5, 9, 11, 12. And the range? 0, 1, 7. Now, there aren't any repeated numbers in this mapping diagram, but if there were repeated numbers, you wouldn't write a repeated number. If 0 happened more than once, you would only write the 0 once. Now let's talk about whether or not it is a function. The 5 only goes to 1, 9 only goes to 7, 11 only goes to 7, and 12 only goes to 0. And if you wrote out these points, we've got 5, 1, 9, 7, 11, 7, and 12, 0. So take a look at the x values. Do you see a repeated x value? No. So it is a function. And I am going to note here the repeated y value. Repeated y values are okay. This might be kind of a weird way to look at it, but here the X value is knowingly dating two people, and that's bad. Here, 9 is dating 7, 11 is dating 7, but that's not really 9 and 11's fault. So they don't know. It's the X's that are important. Focus on the X's. The X's are important. Okay, every time that we use this type of a graph, I like to use this type of a graph because the 5s are clearly marked, so it's easy to count over to find your points. The other nice thing is, if I knew that I was going to have X values up to 15, I could make my origin be here. You could also make your origin be up here or down here. You can move the origin around to suit your needs. That's why I like this type of a graph. But how many of you are lazy and don't want to draw in the X and Y axis every single stinking time? Pretty much all of you, right? So technically, I should tell you that you must draw in your X axis and you must draw in your Y axis. But let's be real, a lot of you aren't going to. So if you don't draw in your X and Y axis, I will assume that this center point is your origin 0, 0. If you want your origin to be somewhere else, you must draw in your X and Y axis. Can we make that agreement as a class? If axes are not drawn, then this center point is 0, 0. Okay, so take a moment and graph these 4 points, and let's see if this relation is a function. So the point 2, 5. 2,
it is
5.
Because there's no repeated X value.
Perfect. This point, -1, 7. 0, 1. 1, -4. This is a function because if you look at the X values, we do not have any repeated X values. What happens if I add this point? 1, 5. So 1, 5 is right there.
Then it wouldn't be a function.
It's not a function. We have an X value of 1. We already had an X value of 1. So you can see in the points that there's a repeated X value. In the picture, I want you to notice that now these 2 points are on the same vertical line. If you put a vertical line through the relation and it touches more than 1 point, that means there's a repeated X value. That means that it's not a function. So that brings us into the vertical line test. If you put vertical lines through the graph and each vertical line only touches 1 point at a time, it is a function. If you draw a vertical line through a graph and it touches at 2 points, then it is not a function. The one on the left, you could put any number of vertical lines through here. Each vertical line is only going to touch 1 point at a time. So this one is a function. What do you think about the middle one?
Function.
It is a function. Take a moment and graph this relation on your own. I'm basically just trying to show you all of the different ways that you might see relations. So we've seen mapping diagrams. We've seen a list of ordered pairs. Now this is a table of values. Plot these points on the graph. Once you get these plotted, you might recognize this shape as a parabola. If you were to connect the dots, it would be a parabola. Is this relation a function? Yes, there are no repeated X values. And if you drop vertical lines down on this graph, a vertical line wouldn't touch more than 1 point at a time. Graphing equations in two variables. I know that some of you from Algebra 1 and from geometry remember how to graph using y equals mx plus b. But the purpose of this particular section is to remind you that if you ever forget how to graph a specific type of thing, you can always use a table of values. So in number 3, if we construct a table of values, we put our x's on the left and our y's on the right, we get to pick x values. So what x values do we want to pick? We should probably pick something negative. Like -2 sounds good. I like to plug 0 in to see what 0 gives us. And something positive, so 2. You are plugging each of these x values into the equation that you are given. So 2 times -2 is -4. -4 plus 1 is -3. Okay. 2 times 0 is 0. 0 plus 1 is 1. 2 times 2 is 4. 4 plus 1 is 5. Now plot those points. Remember, this point right here is 0, 0. So we have -2, -3, 0, 1, and 2, 5.
Basically, for these, we're setting them up. We're setting them up and then see if the possible want this.
Yep. You want at least 2 points. 3 is better to make sure you have a quality graph. And you might have seen me put the ruler up there to get a nice straight line. Your student IDs are about the perfect size to fit across one of these graphs and then draw a straight line around the side. And since you all are supposed to have your student IDs on you so that you can wear them during Wildcat Hour, you could easily just pull out your student ID, lay it down, draw a nice straight line. Looks like I missed a little section right there. Okay, the next graph, y equals -x. Let's pick some x values. Should we do the same ones? -2, 0, and 2? Okay, y equals -x. We are plugging the number in here, so we're taking the number that we chose and basically taking the opposite of it. So the opposite of -2 is 2, the opposite of 0 is 0, and the opposite of 2 is -2. Some of you might think I'm crazy right now, but I'm going to do a table of values. This equation says y equals 2. So my y value is 2, my y value is 2, my y value is 2. Doesn't matter what the x value is, there's no x in that equation, y is always 2. When we plot these, -2, 2, 0, 2, 2, 2. Every single point will sit on the perfect horizontal line, and every point on this line has a y value of 2. Do you remember Hoy and Vux from a long time ago? Is that how you learned it? So this is Hoy. Hoy means horizontal line that has a slope of 0, and the equation looks like y equals a number with no x. Vertical lines are Vux. If you see x equals a number with no y value, then it is a perfect vertical line where every point on that line has an x value of whatever that number is. We ran out of time, so here's some information about linear functions and function notation. Make sure you look at all of this.